This lesson is on factoring. We're going to look at two methods of factoring to begin with, greatest common factor, and followed by the grouping technique. What is a factor anyway? Well, a factor is an integer that divides evenly into a product. For example, 3 times 5 gives us 15. Therefore, we know that 15 will be evenly divided by 5 and 3. So 3 and 5 are the factors, and 15 is our product. So here, 3 times 5 is our factored form, and 15 is what it equals to. It's kind of like a molecule. The factors are the little tiny components that are clustered together to give you the final product. Let's take a look at the following. Here we've got 6x times 3x minus 2. So here we've got factors 6 times x times 3x minus 2, and this is actually called factored form because it's all broken down into the bits and pieces all multiplied together. One way to notice that it's in factored form is to note that any pluses or minuses are contained within brackets. So we could use the distribution property to expand. 6x times 3x gives us 18x squared. 6x times negative 2 gives us negative 12x. Now, this here is called expanded form. Up until now, we have been expanding expressions, and in this whole unit we're going to be factoring. Factoring is the process of getting an expression back into factored form. So how do we go back into factored form? If we are only given the expanded form of 18x squared minus 12x, how do we get back into something times two terms? We've got two terms, so we have to keep two terms. Well, let's break this down and see what's in the first term. In the first term, positive 18x squared, you've got 18, which is made up of 2 times 9, which is made up of 3 times 3. So that's really 2 times a 3 times a 3 times x squared, which is x times x. And here in the second bin, we've got negative 12x, and 12 could be split into 3 times 4, which is 2 times 2. So here we've got negative 3 times 2 times 2 times x. So we've broken it down, and you can notice that there are some common factors in both bins. You have a 2 times a 3 in both. So what that tells us is that both of these numbers could be divided by, evenly divided by 6. They could also be divided evenly by an x. You'll notice eventually that when you're looking at your variables, you can look at basically the lowest exponent. Exponent 1 versus exponent 2. Well, only 1 is common to both. So that tells us that 6x can be taken out. 6x is called the greatest common factor because it is the biggest number that will divide both 18x squared and 12x. So once we find this greatest common factor, we can say, well, what would it have been multiplied by to get back to the original question? Well, 6x would have to be multiplied by 3x and also by negative 2 to give us our original expression. So this here is factored form, and you can always check your work by multiplying it back out and seeing if it is equivalent to 18x squared minus 12x. Let's focus a little more on the greatest common factor. These examples here are asking us to find the greatest common factor. This is a preliminary step before you begin to factor the greatest common factor out in front of the bracket. So here all they're asking for is just the greatest common factor. Some of you may recall a method for finding the greatest common factor, and it often involves breaking the number down into its prime factors. So 150 is 15 times 10, and 15 is 3 times 5, 10 is 2 times 5. 90 is 9 times 10, 9 is 3 times 3, 10 is 2 times 5. So we have prime factorizations for both numbers. We basically want to see what is common for both numbers. You could, if you'd like, arrange them. So 3 times 5 times 2 times 5 is the first number. And below, you could, if you want to find common things, you can just write them right below. So the second number is 3 times 3 times 2 times 5. So what factors are common? Well, a factor of 3, a factor of 2, and a factor of 5 are common. So because these are prime factors, we can consider them all together. 3 times 2 times 5, any combination of those will divide both 150 and 90. So the biggest possible number we can make out of 3, 2, and 5 in the world of multiplication is 6 times 5, which is 30. Some of you may already know, 30 is the biggest number that fits into or divides evenly into 90 and 150. So this is just one way of finding the greatest common factor. You may have your own. Let's continue. Here we're asked to find the greatest common factor of 18x squared y and negative 12xy squared. We have already found the greatest common factor of 18 and 12, and we found that to be 6. Now we want to find the variable common factors. So here we've got x squared y and xy squared. So we want to be able to have this greatest common factor be able to divide both the first and the second. And I had mentioned in the previous slide that really you're just looking for the lowest exponent on each variable, because this will definitely divide by x, but this one won't divide by anything more than x. It won't divide by 8x squared because you'll have something left in the bottom and you don't want that. So x is the lowest degree of our x's, and also for y. So I would argue that 6xy is the greatest common factor. If you really like, you could write all the factors out. So this would be 3 times 2 times 3 times x times y, 3 times 2 times 2 times times y, and figure out what the common ones are. And that will leave you with the same result. Notice I haven't done anything with the negative. For greatest common factor answers, you don't need to worry about including negatives. We will deal with that when we have to factor expressions. So here's an even more complicated one. Notice this bracket x plus 3 is just like one of our variables. Here it's to the power of 2, here's to the power of 1, here it's to the power of 1. So we're looking for the greatest common factor between 14, 21, and 7, and many of you will agree that 7 is the biggest number that will divide all three of those numbers. The lowest exponent on x is x to the 1, x to the 2, x to the 1. So 1 is the lowest exponent. What else do we have here? We have a y. A y has an exponent of 1 here, but if it's not present, remember it's as if it was y to the 0 and y to the 0. So 0 is the lowest exponent, therefore there is no y in our greatest common factor. It would not divide out of these ones. The last factor to deal with is x plus 3, and the lowest exponent on that is also 1. So 7x bracket x plus 3 is our greatest common factor. So generalization is that the greatest common factor of your terms is found by taking the greatest common factor of your coefficients, your numbers, as before, multiplied by the lowest degree of each variable. Let's take a look at some factoring examples where we need to take out the greatest common factor. Remember, when you're factoring out a greatest common factor, you will always be left with the same number of terms. We first want to identify what the greatest common factor is. What is the greatest common factor of 6, 4, and 8? Greatest common factor of that is 2. We can divide 6, 4, and 8 by 2, and that is the biggest number we can divide them all by. Let's take a look at the variables. So what number of x's can we divide all three terms by? Well, there's an x in the first term, x in the second term, but no x in the third term. So recall, we're looking for the lowest degree of x. X to the 1, x to the 1, and if there's no x, that's x to the 0. 0 is the lowest degree. Therefore, no x's are coming out into the greatest common factor because you cannot divide all three of them by x because you'd be left with an x in the denominator, which you don't want. We want to keep these polynomials. So no x factors out. However, let's look at the y's. There's 3 y's in the first term, 1 y in the second, and 1 y in the third. So we can divide all 3 by a y. We can factor out a y. So the greatest common factor is 2y. Now we want to identify what we would multiply by to get the first term, what we would multiply by to get the second, and the third. So we're working backwards here. So 2y needs to multiply by something to give us 6xy cubed. So you'll be multiplying by 3, by an x, and by 2 more y's. The next term will be positive, 2y times 2. 2 times 2 gives us 4. Y times no y's gives us y, and we still need an x. And the third one, we want to achieve a negative 8y. So we want negative and 4 because negative 4 times 2y is negative 8y. So you can always double check your factored form, multiply it out, and see if it gives you back the expanded form. However, do remember that your answer for factoring is going to have brackets, and all your pluses and minuses are going to be contained within the brackets. There will be no loose pluses or minuses in a factored form. So this question is complete at this moment. I want to offer you an alternate route here. If you're having troubles with this step of figuring out what you would multiply by, you could think, well, the same thing as asking what times 2y gives us 6xy cubed would be to say 6xy cubed divided by 2y. So you could take every single one of these, and yes, you could sort of like divide each one by 2y. However, if you're doing that, don't forget to write the 2y outside, because essentially you can multiply by 2y and divide by 2y, and multiplying and dividing cancels out, leaving you with the same expression, just written in a different way, in a factored form. So this will allow you to simplify directly. However, eventually you will want to be able to just identify it right away or do this division sort of in your head. Notice 6 divided by 2 gives us 3, x stays, and y goes to the 2. Plus 2, y's cancel, x stays, and 4, just like that. Let's look at the next example. So what is the greatest common factor? The greatest common factor of 3, 5, and 2 is 1. So that's it. And then for our letters, what is the lowest exponent on x? X is to the 5th, to the 3rd, and to the 4th. So to the 3rd, we'll be able to divide out of all 3 of those terms. How about our y term? Y is to the 1, to the 2, and to the 3. So to the 1 will be the greatest common factor because it will divide out of all 3 terms. And z, there's z to the 1, z to the 0, and z to the 0. So no z's can come out of all 3 of them. Now we look at what's left. And sometimes it's an option you may take. Sometimes you want to have the leading term, the first term, to be positive. So you could take out a negative if you like. If you don't, that's fine in this case, but eventually you'll notice that it's going to aid you to take out the negative and change all the signs so that your leading term is positive. So let's try that here. Let's take out the negative, so that means this will be positive, positive, and negative, with that negative applying to all 3. Alright, x cubed y times what gives us 3x to the 5y? Well, we need to multiply by 3, x to the 2, and we already have a y. So let's just double check that here. X cubed times x squared gives us x to the 5, 1 times 3, negative 1 times 3 gives us negative 3, and y times no y's gives us a y. Check. Next term will now be positive because we factored out a negative. And the 5 stays. We didn't take out any numbers. The x cubed has been divided out. 1y was divided out. And a z still needs to be there. You can double check by multiplying and it should give it back to you there. And the last term will now be negative because we factored the negative out, a 2, and then we need another x and another 2 y's. Let's double check that. Negative 1 times negative 2 is positive 2, x cubed times x is x to the 4, and y times y squared is y cubed. Let's continue on. Here we have 2 terms. Notice that this here does not separate terms because it's contained in a bracket. Only loose positives and negatives separate your terms. The greatest common factor of 10 and 15 is 5. Lowest exponent on x is x to the 1. Lowest exponent on 3 minus x is 2. Now we can divide both of those by our greatest common factor. And see what's left. In our first term, negative 15 over 5 is negative 3. X over x is gone, simplifies to 1. And we have 1 left of the 3 minus x. Plus 10 over 5 is 2. X to the 2 over x is x. And these both cancel out. Let's just clean up this last bit here. So that would be giving us negative 9 plus 3x plus 2x, which is basically negative 9 plus 5x. So you could just write that as negative 9 plus 5x. Yikes, hey? So this is an example of a higher level question. It's just got more going on with it, but the same process applies. I'd like to move on to something that's actually really going to be very important for you. As you begin to factor, you'll start noticing something, and you'll start noticing that sometimes you'll have a negative in the leading coefficient. And you might not want it to be there. Eventually you'll see why. However, let's discuss how we would get rid of that negative. Well, this is essentially negative 1 times x plus 7. Could we divide both of those by a negative 1 and simultaneously multiply it by negative 1? Well, yes, multiplying and dividing by the same thing will counteract itself and it's still the same. So let's negative 1 times x minus 7, which is also written as negative x minus 7. Sometimes it is actually quite useful to factor out the negative. Especially if it's in the leading coefficient. Oh no! What if our greatest common factor is 1? Well, you can see in this example, we don't actually have a common factor that is common to all 4 of these terms. If you only have 3 terms or less, that's fine, you just leave it, you say greatest common factor is 1. But if you have 4 terms, there is something special that we can do called the grouping technique. We can take 2 terms at a time and factor them separately. Now, in the first 2 terms, you've got a greatest common factor of 2. You're left with x plus y. In the second 2, you want to have the exact same bracket because then it will be a common term. Now, can we make it that? Is there a greatest common factor between these 2? Well, it's 5z, and also you want these signs to be the same. So you want to factor out a negative and therefore changing both those signs, giving us x and plus y. Now what's happened is we have a common factor, and what has also happened is our 4 terms became 2 terms. So what is the greatest common factor between these 2 terms? The bracket is the common factor. The bracket is outside, and now we're looking at what is left inside. Let's just take that and highlight it. We've got the x plus y term that is contained in both of these terms. This is multiplied, multiplied, multiplied. These are our clusters, and the x plus y has now been factored out as a common factor, which leaves us with a 2 minus a 5z in the other bracket. And this is our factored form. Notice all your pluses and minuses are not loose. They are trapped within brackets. And that is one way to check out if something is factored or not. You never want to have loose positives or negatives. Let's check out some more of these examples. So here we've got 4 terms. 4 terms means we need to take 2 at a time. So let's take the first 2. What's the greatest common factor? B. Gives us 3a minus b. Check it. B times 3a, 3ab. B times negative b is negative b squared. In the second one, we want to have the exact same bracket remaining. However, here you'll notice that there is no common factor. The greatest common factor is 1. There's nothing we can do except for maybe change the sign. Do we want to change the sign? Well, you'll notice here our A term is written first and our B term is written second. So maybe let's rearrange these so that that says positive 3a minus b. All I've done is rearrange them. So do I need to change the signs with a negative greatest common factor? No, we don't, because this is the same. So notice when you're doing grouping, you really want the same bracket so that you can take it out as a common factor and look at what's left to complete your question. Another example here, you may have some greatest common factors, but you still have 4 terms. So if you have 4 terms, remember to factor out your greatest common factor first, if possible, whenever possible. This rule goes for all factoring. Greatest common factor is the most important one. It's going to help you out and make numbers smaller. So let's see, is there a greatest common factor? Yes, we've got a 5, x's, no, y's, no. But z's, we've got z's that go through the whole thing. So what's left? Let me write this in a different color so that you see what's left. Negative 2 xy minus 2 x z plus 1 y plus 1 z. So we've got this blue expression to now factor using grouping. So we're going to keep the 5z out, leave it out, and pretend it's just hanging out. Remember to rewrite it at the end. So let's work on the blue step. Combine the terms. Here we've got a common factor of negative 2x, leaving us with y plus z. And here we have no common factor of 1, and you can just write it in this format so it's easier to see. So we've got this common factor of y plus z that's coming out, and we're left with a negative 2x plus 1. Notice the 5z needs to be written at the end to complete your question.